All right, let's talk about something that could save you from a really dangerous situation this winter. We're diving into your car battery, and specifically what happens when it gets frozen solid. You know the feeling. It's one of those brutally cold mornings where the air just hurts. You're already running late, and your car is completely dead. So, your first instinct, of course, is to go grab the jumper cables. But seriously, stop. Before you do anything else, just put those cables down. The decision you make in the next 30 seconds is absolutely crucial. That first impulse to just hook up a charger or jump it could be the single most dangerous mistake you make all winter. Before you connect anything to those terminals, you have to ask one simple question. Is my battery frozen? And listen, I'm not being dramatic here. If you ask any mechanic or tow truck driver, they'll tell you stories. Trying to jumpstart a frozen battery creates a sealed, pressurized box full of explosive hydrogen gas. You are literally turning that battery into a bomb. So here it is, the one rule you have to remember, and it's an absolute. If you have any suspicion that your battery is frozen, do not apply any electrical current. No jumping, no charging, not even testing it. If it's a block of ice, electricity is completely off the table, period. So what makes it so incredibly dangerous? To understand that, we've got to look at the science behind it. It's a pretty fascinating and, frankly, kind of terrifying mix of chemistry and physics. This slide right here tells the whole story. See, a healthy, fully charged battery is basically freeze-proof. Its electrolyte is about 35% sulfuric acid, which acts like antifreeze, protecting it all the way down to -76 degrees. But as a battery discharges, that acid gets used up, and what's left behind is mostly just water. And as we all know, water freezes at 32 degrees Fahrenheit. And this is the trap that so many people fall into. Your battery didn't freeze just because it got cold. It froze because it was already dead or dying. Maybe a dome light was left on, or maybe the battery was just at the end of its life. The cold was just the final step in a chain reaction that turned your battery from a power source into a solid block of ice. So, when you try to force an electrical current through that block of ice, you create a perfect storm for an explosion. Two things happen. First, the electricity starts creating hydrogen gas, but the ice is blocking all the vents, so that pressure has nowhere to go. It just builds and builds. Second, the water expanding into ice has probably bent or even cracked the delicate lead plates inside. If two of those plates touch, you get an internal spark. A spark inside a pressurized box full of flammable gas. It's not a good combination. Okay, so you get the danger. Now for the most important part. How do you actually check for it? Let's walk through a super simple 30-second inspection you have to do before you even think about grabbing those jumper cables. This is the big one, the number one telltale sign. Look at the sides of the battery case. They should be perfectly flat. If they look swollen, bulging, or kind of bowed out like a balloon, stop right there. That's a deal breaker. It means the ice inside has expanded and has almost certainly caused permanent, fatal damage. Don't charge it, don't jump it. That battery is done. Beyond the swollen sides, look for other clues. Can you see any frost or ice actually forming on the case? If you can safely rock the battery a little, does it feel like a solid brick? You should hear liquid sloshing around in there. If you don't, it's probably frozen. And finally, grab your phone's flashlight and look closely for any hairline cracks. Any of these signs means you need to be extremely careful. So what if the case isn't swollen or cracked, but you're still pretty sure it's a solid block of ice inside? Well, you might be able to save it, but this process requires one thing above all else: patience. You absolutely cannot rush this. The protocol here is simple, but it is non-negotiable. You have to carefully disconnect and remove the battery from the car. Bring it inside to a safe place, like a garage or even a bathtub or utility sink, somewhere that a potential acid leak won't cause damage. And then you just wait. Let it thaw out naturally at room temperature. Once it's completely thawed, give it one more thorough inspection before you even think about putting a charger on it. And when I say patience, I really mean it. A big, dense car battery can easily take a full 24 to 48 hours to thaw all the way to its core. The outside might feel warm to the touch long before the center is liquid again. Trying to charge a partially frozen battery is just as dangerous as charging a fully frozen one. You have to wait it out. And let me be perfectly clear about this. Do not try to speed this up. No hair dryers, no heat guns, don't put it near a space heater. These are all terrible ideas that can cause the case to warp and increase the risk of something going very, very wrong. Room temperature is the only safe way. So you've thought it out, you've inspected it again, and it looks okay. But is it really safe to use? This brings us to that final, critical decision, knowing when it's time to just call it quits. Because your safety is always worth more than the cost of a new battery. Here's your definitive checklist. If that battery is over 3 years old, if it had any bulging whatsoever, or if it just won't hold a proper charge after you've slowly brought it back, it's done for. And really pay attention to your senses while charging. If you smell rotten eggs, that's sulfur, or if the battery gets hot to the touch, those are immediate red flags. Unplug it right away. It's time for replacement. You have to understand this. Even if you do everything right, you thaw it slowly, you charge it correctly, a battery that has been frozen solid is permanently damaged. The ice has wrecked the delicate lead plates inside. Its reliability is gone, and you've basically cut its remaining lifespan in half at best. You're now driving around with a ticking clock under your hood. And that really brings us to the final thought here. When you're standing out there in the freezing cold and you're so tempted to just hook up the cables and hope for the best, ask yourself this one question. Knowing that the worst-case scenario is an explosion of plastic and sulfuric acid, is a $150 battery really worth that risk? Stay safe out there.